Hello, welcome back to the channel. So in this video we are introducing tangents to the circles that we have been talking about, both circles whereby the center is at the origin, as well as circles whereby the center is not at the origin. We can introduce what we call a tangent. So with regards to tangents, don't stress yourself too much. Tangents are just straight lines which touch the circle at only one point. You can have other straight lines which touch the circle rather at more than one point, like this line or that line or that line. You can see it, each of these lines, they touch the circle at 2 points, like that. So if it's a line, it touches the circle at more than 1 point, that line is not a tangent to the circle. So it's not the line that we're interested in. We're interested in a line like this one that is given here, which only touches the circle at 1 point. At that point where the tangent touches the circle, it is actually perpendicular to the radius of that circle. That is just a statement that you need to remember from Euclidean geometry. It was, I think, proved there, but that's a story for another day. Okay, with that situation, let's do an example here so that we understand how we can apply that theory. Suppose we are required to show that a straight line, which is represented by the equation y equals to minus x minus 4, is a tangent to the circle, which is represented by that equation there. How are you going to show or prove that this straight line is actually a tangent to the circle? You need to prove that this straight line, it touches this circle at only 1 point. To prove that, you just need to solve the two equations simultaneously and show that there is only 1 point of intersection between the two equations, or between the two graphs. If you can remember the fact that a circle is also a graph and a straight line is a graph. So whenever you have two graphs meeting, to find the points of intersection, if you remember from simultaneous equations, you usually have one of the equations being an equation of a parabola and the other one being the equation of a straight line. So to find the intersection points, you were solving the equation simultaneously. So even here we are still doing that, because a circle is just a graph, a line is a graph as well. So to do the whole thing and solve this thing, we just wrote the equations as I've written them like that. And then the first thing to do rather is to substitute equation 1, since it's the simpler equation, into the complicated equation, which is equation 2. So when we do the substitution, what are we going to have? We're going to have a situation like this: x minus 1 all squared plus, instead of y, you're going to put minus x minus 4, like that, and then plus 1 all squared equals to 8. From here, we just need to simplify. So how do we simplify this? It's just x minus 1 all squared plus, in these brackets, we're going to have minus x minus 3 all squared equals to 8. From there, what do we have? This x minus 1, we can expand it. When we expand it, it's going to be x minus 1 like this, x minus 1 like that, and then plus minus x minus 3 minus x minus 3 equals to 8. And then we simplify. This is x squared, sorry, this is x squared minus x, that is minus 2x plus 1, like that. And then we have plus x squared, okay, plus 3x, that is plus 6x, minus 3 times minus 3, that is positive 9, and then everything is equals to 8. Now we just add the like terms. We have 2x squared minus x plus 6x, that is minus 2x plus 6x, that is plus 4x. And then what is happening? We are left with 9. That 9 we have to subtract 9 plus 1, that is 10. 10 subtracting the 8, we're going to have 2 here. Okay, then we just divide throughout by 2. We'll have x squared plus 2x plus 1 equals to 0. This, when you factorize it, is x plus 1 and x plus 1. As you can see, it therefore means x plus 1 is equals to 0, which therefore means x is actually equals to negative 1. So there's only one point of intersection. To find the y value for that point of intersection, we just need to substitute x equals to negative 1. Just gonna erase that. Sorry. Substitute x equals to negative 1 into the simpler equation, which is equation 1. Therefore, we say y is going to be equals to minus negative 1, negative minus 4, like that. Therefore, y equals to, that is basically 1 minus 4, which is negative 3. So the point of intersection, it's this, negative 1 and negative 3, which is which therefore means, therefore the straight line, just to conclude now, we only have one point of intersection. And remember, the whole idea of doing this exercise was to show that that straight line, it's a tangent to the circle. Therefore, the straight line y equals to minus x minus 4 is a tangent to the circle. To the circle, which circle? This circle, which is given by this equation. Reason being, you put the because the straight line it intersects with the circle at only one point, which is -3. I mean -1 and -3, not -3 and -1 like this. And then that's it. It's good enough. You've proven that there's only one point of intersection, and this is that point of intersection, and then you are done. That's how you would actually approach this question. See you in the next video.